It's around 2.2 meters per second.
2.2
2.
meter per second. Okay, good. Can you, yeah, this is in 2.2 meter per second. Can you convert this? If suppose if I had not asked you meter per second and I asked you to convert it into kilometer per hour, how do I convert this? If the answer was to be given in kilometer per hour, how do you do that?
It'll be 2.2 into 5 by 18.
2.2 into 5 by 18. See, remember, 1 kilometer per hour can be converted into meter per second
Yeah.
as 5 by 18 meter per second. Okay. So if I am given
Yeah.
meter per second, then I should get this as 18 by 5. 1 meter per second is 18 by 5 kilometer per hour. Is this clear?
Yeah.
Okay. So therefore, when I have 2.2 meter per second, which will be 2.2 multiplied by 18 by 5 kilometer per hour. So what is the answer you get here?
Um.
7.92
Yeah.
kilometer per hour. Okay. Figure shows the speed time graph for a train traveling on a different part of the track. Okay. Speed is given here, time is given here. It's a VT graph here. Determine the total distance traveled by the train on this part of the track. How do we do this? Speed time graph for a train traveling on a different part of the track. Okay.
It would be the area under the graph.
Area
So
under the graph. Yeah, tell me what is the value of it. So there is a line here. There's a thin line that has been shown over here. Okay, then
it'll be half into 3.5
half into 3.5 into,
into 14 plus 6.
is it 14? What is this value? This is 4 and this is 10. Okay,
10.
be
So
14 plus
6.
6. 14 plus 6.
So the
Yeah,
answer
it will
is
be 35.
35
Unit
meters.
meters. The total distance traveled by the train and part of this track is 35 meters. Okay. A 250cc beaker with some liquid is shown in the figure. Unknown volume of the liquid beaker is given. A student has a measuring cylinder and a balance. Describe an experiment to determine the density of the liquid. How do you find the density of the liquid here? You are being given a measuring cylinder and you are given a balance. So what do you do? How do you work with?
Um.
This is for 5 marks. So don't say, oh, I measured mass, I measured volume, I got the answer. So you should mention it in detail.
Well, first you can pour the liquid into the measuring cylinder and take the reading of the volume.
Yes, pour the liquid in the measuring cylinder, and find the volume. Find the volume of the liquid. And then second
And
step.
then before pouring the water back in the beaker, um, you can weigh the beaker, like find out the weight of the beaker, and then pour the liquid back in and measure that weight.
Okay, weigh the empty beaker and beaker with liquid, right?
And then, yeah, then subtract the weight of the
Yeah,
empty
so
beaker
while you
from.
write this, you have to write where the empty beaker, okay, and yeah, let the mass of empty beaker, because you're doing an experiment. So somewhere you have to mention the procedure here. Mass of empty beaker is equal to M1 and with filled in liquid is equal to M2. Then what is the next step? Third step?
It would be M2 minus M1.
Mass of the liquid
So yeah.
is equal to M2 minus M1. Then what's the fourth step?
Uh, then you wait. You
Yeah.
divide the mass by the
Volume. See, first thing is read the question once again. This is for 5 marks. The experiment. Describe an experiment here. When I say about an experiment should have at least 3 trials. And then after 3 trials, you have to take the average. And after this, you do the calculations, and then get the result. Okay. So therefore, you are now describing an experiment here. So you have to describe here. The term describe tells you that you have to tell all these things here. Now, while you write all this, what is that you have written here? You have poured the liquid, measuring cylinder, filed the volume. You mentioned all this, which means you have mentioned only about the experimental description. But this part is missing, this part is missing, this part is missing. Maybe you will incorporate this also. This you will write it, this you will write it. But these two are missing. So even though you write it completely, legibly, clearly, you will only get 3 marks here. Okay. So these two are very, very important.
yeah.
So what should you do now?
So then
Repeat the experiment. Repeat
yeah.
the above procedure for 3 different volumes. And here you say 50, 100, 150 ml of liquid. Okay. And find or determine the mass of the and determine the volumes of the liquids. Or determine the mass of the liquids.
Yeah.
Then what you are going to do? You are going to write the density of the liquid is equal to mass by 1. So if you write so much, then definitely you will get full marks.
Yeah.
Okay, just a minute. There's a lot of noise outside. Okay. Right. So this will give you 5 marks now. Suggest the unit of density used by the student. What is the density unit?
Um, it could be uh
This is only 1 mark, so don't use a could be one, right? Give me only one answer here.
grams by centimeter cube.
See, you are writing an exam which is in terms of, which is now in 2021 now. Okay, don't use
Yeah.
your gram per cc here. Because anywhere here, have I mentioned anything in terms of gram per cc? You have
No.
to here also see it is ml here, you have to convert this. Okay, this should be meter cube over here. Or maybe once you write this in meter cube, then you have to convert ml, then you have to convert it into meter cube. Okay, so now if that is the case, you can write gram per centimeter cube, or you can directly mention this as kg per meter cube. Okay.
Yeah.
Right, now let us move on to the next one. Figure shows a block of polythene. Polythene floats in water. Explain why polythene floats. What is the reason?
Because the density is
1 mark. Yeah.
it's yeah, it has a lower density than water.
Density of polythene is density lesser than the density of water, and hence the polythene floats out. Then the weight of the polythene block is 0.84 Newton. Calculate the mass of the block.
Um, 0.084
Okay, again the
kg.
same mistake. This for 3-mark question. So you have to write weight is equal to m into g. And here the weight is given as 0.84 is equal to mass which is unknown multiplied by 10. This implies m should be equal to 0.84 divided by 10, which should be 0.084 unit
Kgs.
kg. Okay, so you will get 1 mark here, you will get 1 mark for the calculation, 1 mark for the answer. Okay, the breaking scheme is something like this. So if you just use your calculator, okay, you will only get 1 mark here. But this is where people lose marks. So you have to be very careful. So always while before answering the question, see to it that what is the distribution, and based on it you answer it. If the same question was asked for 1 mark, you need not do all these things. You can just directly write 0.084. Is this clear?
Yeah.
Right. Okay, now let us move on to the next one. Figure 3.1 shows the vertical forces on a rocket. Thrust 74.2 Newton. Air resistance is given. Weight is given over here. Okay, rocket is moving up. Calculate the resultant force on the rocket. Resultant force, direction, we have asked. Deduce the speed and direction of motion after 5 seconds. Indicate what is being asked. Okay, so calculate the resultant force in the rocket. What is the resultant force? How do you find resultant force?
Um, the force acting in one direction minus the force acting in the opposite
Tell
direction.
me what is the value?
Sorry. So 74.2 minus 45.4.
45.4. Yeah. So what is the value of it?
28.8.
28.8 Newton. And what is the direction?
Uh, it's upwards.
Upward direction. You can say this. So therefore, now resultant force, you get 1 mark here, upwards direction. Okay, so totally you get 3 marks here. If your answer is right, you will get this. Then figure B shows the speed and direction of motion of an object at a point in time. Okay, so it's a different question, 150 meter per second object. The resultant force on the object is 0 for 10 seconds. Deduce the speed and the direction of motion after 5 seconds. Indicate the speed and direction of the object by drawing a labeled arrow next to the object in figure 3.3. Just wait. This is my 3.3. This is my figure 3.3. So now the object is moving like this. Speed and direction of the object given time. The resultant force on the object is 0 for 10 seconds. Okay. That is the speed. Wait. Pull this one downwards. That is the speed and direction of the motion after 5 seconds. After 5 seconds, what will be the speed and direction of motion? Speed and direction after 5 seconds. Okay. Indicate the speed and direction of the object. That is the speed and direction of the motion after 5 seconds. What will be it? Okay, let us first answer this one. What will be the speed and direction of the object after 5 seconds? You have to mention it in the same diagram. Read the question once again and deduce it based on it.
Yeah.
When there is no force acting on the object, will the velocity change?
No.
So which means the direction is also in this direction and the speed is also 150 meters per second, correct?
Yeah.
So therefore, it is again 150 meter per second and the direction is also in this direction. Indicate the speed and direction of the object by drawing a labeled arrow. Okay, that's what we have done. Okay, next. Let us move to the next one also. This is something which we have done already done this, I think. Speed time graph, we have done this. Calculate the distance that the car travels between 60 and 100 seconds. between 60 and 100 seconds. Before that, we have this one. Okay, let us solve this one. On figure 1.1, the labels W, X, Y, Z shows the points where the car's motion changes. W, X, Y, Z. Okay. On figure 1.2, draw a line from each section of the graph to correct description of the motion. Match the following, nothing else. Section of the graph from W to X. From W to X, what is happening? It's a plot of speed versus time.
Accelerating.
It is accelerating. Okay. Then from X to Y.
It's a constant speed.
Right. From X to Y, it's constant speed. Y to Z.
It's decelerating.
Decelerating. Okay. Calculate the distance that the car travels between 60 and 100 seconds. Between 60 and 100 seconds. 60 is here and 100 is here. Distance that the car travels between 60 and 100.
It's the distance under, sorry, the area under the graph. So it'll be half into 20 into 40.
Half into 20 into 40, which should be equal to 400 units.
Meters.
400. Shows the car's acceleration is greater than its deceleration. Explain how the graph looks like. Shows this. How do you understand the acceleration is more than the deceleration?
Well, you can find the slope of the graph in those.
Okay. Can you tell me what are the slopes?
So
So you should write slope Wx is equal to
20 minus 0 by 30 minus 0. So it's
divided by 30, which should be equal to 2 by 3. Unit?
Yeah.
Unit?
2 by 3 meters per second square.
Meter per second square. Then slope Yz is equal to
20 by 40.
Do we have 20 there? 20, okay. So we'll write this as 20 minus 0 divided by 40, which would be equal to half meter per second square. So then you have to conclude, saying that slope Wx is greater than slope Yz. This implies acceleration Wx is greater than acceleration Yz. Okay?
Yeah.
Fine then. So we will stop here for today. And then we'll continue later on. Next class.
Okay.